Hey, so we are graphing systems of equations where one of our equations is in standard form. We could give you problems where both equations are in standard form, but we figured let's keep half the things in slope-intercept form. I don't know. That's the decision we made at some point. So go ahead and put your name on here. Okay, like I said, like your quick write was based on 2.7. We graphed equations in standard form. We had two methods. We are going to review both methods real quick. For this problem, this equation is one of your equations that's in this first one. And so you'll be able to see it happening either way here. And then for the other ones, we'll do one with intercepts, one with converting. So, to graph equation in standard form, first option is to convert. Converting is two steps. You've got to first subtract across your x term. So I'm going to subtract 2x from both sides. I get negative 3y equals negative 2x minus 12. I put the x term first because that's closer to being y equals mx plus b. What do I need to do now to get y by itself? Divide by the negative 3. Awesome. So divide everything by the negative 3. I get y equals negative 2 divided by negative 3. We're going to leave that as a fraction, but that negative divided by a negative is going to become positive. So it's going to be 2/3 x. And then negative 12 divided by negative 3 is going to be positive 4. So that is how I would convert that if I wanted to convert it. Okay. Any questions about converting? Okay, it sounds like most of us in this hour preferred intercepts. So for intercepts method, we are going to take this term, this 2x, we're going to set it equal to negative 12. The reason why we can do that is we can pretend like we're plugging in a 0 for y there. So negative 3 times 0 would just be 0. So 2x minus 0 is just 2x. So we're going to solve 2x equals negative 12. Divide both sides by 2. And I get x equals negative 6, which can be my x-intercept. It's not that it can be, that is my x-intercept. Okay, same thing to find my y-intercept. I would be plugging in 0 for x. So 2 times 0 is just 2. Or sorry, 2 times 0 is just 0. 0 minus 3y is just negative 3y. So I just have negative 3y equals negative 12. I'm going to divide both sides by negative 3. I'll get y equals negative divided by negative. That'll be positive 4. And that'll be my y-intercept. Okay. Any questions about, I guess, not any questions about either method. Does everyone understand at least one of the methods? Okay. So then, go take either method that you prefer and graph it on this graph, because our first equation here is that equation. So using the work we just did, you can either graph 2/3 x plus 4, or you can graph your x-intercept and y-intercept. Since more people said they preferred that, I'm going to do that. I'm going to graph an x-intercept at negative 6 and a y-intercept at positive 4. Okay. Regardless of whether you did the slope-intercept form one or the converted one, you should get a line that looks like this. Okay, from there, we have one other line to graph, so we're going to graph it. It is y equals negative 1/3 x plus 1. So I'll start at a y-intercept of 1. I'm going to graph slope of negative 1/3. So I'm going to go down 1, right 3, down 1, right 3. Haven't crossed yet, so I need to go up and to the left. So if I go up 1, left 3, that's where it's going to cross, up 1, left 3. Okay, my intersection there, my solution, is the point negative 3, 2. I go left 3, up 2. That is my solution. All right, any questions on either of those problems, or on either of those lines, and therefore that one big problem? All right, we've got two more. The next one I'm going to convert, the last one I'm going to do intercepts for. If you are a person that truly hates converting, and or vice versa, and you want to do the other method in notes, and meet me at the end. Make sure you get the same line as me. If you don't, ask about it here in a second. If you can't figure out your mistake, to figure out your mistake, okay? So this one, I'm going to graph that y equals 2x minus 7 first, because it's on there first. So I'll start that one at negative 7. I'm going to graph a slope of 2. So I'm going to go up 2, right 1. All the way across my graph. Okay, if you want to do intercepts on your own, you are welcome to do intercepts on your own for the other one and meet me at the end. I'm going to convert it. So I'm going to subtract 2x from both sides. That's going to give me 4y equals negative 2x minus 8. And I'll divide both sides by 4. I'll get y equals negative 2 over 4 will be negative 1/2 x. And then negative 8 divided by 4 will be negative 2. So I'll go start graphing that one at a y-intercept of negative 2. And my slope is negative 1/2, so I'll go down 1, right 2, and I'll cross right away. Down 1, right 2. That one crossed right away. So the point at which those crossed was 2 to the right, down 3, so 2, negative 3. If you chose to do intercepts, you should have gotten a y-intercept at negative 2, because guess what? The y-intercept on both would be the same. And you should have gotten an x-intercept at negative 4. So make sure that if you chose to do intercepts, you got those two intercepts, you got the same intersection. Okay. Any questions on that one? got one last problem on the back here. We've got 6x minus 3y equals 12, and y equals 2x minus 4. I'm going to do intercepts on this one. If you genuinely prefer converting and would prefer to convert, you may convert on this one and meet us at the end as well. But I'm going to do intercepts, so I'm going to do that 6x equals 12. Divide both sides by 6. Get x equals 2. Go ahead and graph that. I'm thinking about it. X equals 2. Then for for negative 3y equals 12, that's how I'm going to get my y-intercept. I'm going to divide both sides by negative 3. I'll get y equals negative 4. Okay. Any questions on the intercepts of that one? Okay. So then we would go try to graph the other one, which is y equals 2x minus 4. My y-intercept would be right here. My slope would be 2. So I'll go up 2, right 1, up 2, right 1, up 2, right 1. What do you guys notice? They're the same line. So if I have two lines that are the same line, all of the points along the line, and it's not just those points, it's every single point in between. There's like an infinite number of points in between. That's why it's called infinite solutions. So we have infinite solutions because they end up being the same line. So on these ones, where they're not both given to you in slope-intercept form, you don't always see that it's going to be infinite solutions before you start. All right, let me stop my video. Bye, video.